is we're going to talk about polygons. Now, to classify polygons, polygons have 4 plus sides. Okay, polygons have 4 plus sides. Find some space on your back to here. Still working on classifying polygons. In order to be a polygon, we have to have 4 plus sides. What else do you think in order to be a polygon or considered a regular? Straight lines. So make these notes. We have to have straight lines. What else do you think? They have to connect. What else? Can they be like wacky indentions?
Yes. No. Actually, wait, yes. Wait, no. Yes.
Nope.
Yeah, because wacky.
No, because blue.
That's a whack.
It's a horror.
Yeah, but red.
Whack.
What else do we know about regular polygons? What do you think the angles and the sides have to be? What's the word in geometry? Yep. Congruent angles and sides. So you're going to look for those 4 things in order to see if it's a regular polygon or not. Okay? So I'm going to fast forward paper somewhere. We're going to start naming these. What's a 4-sided shape called? Square. What's another way you can call it?
Rectangle.
Rectangle. One other way. What?
Rhombus.
Okay. What's the word for 4? Quad. So quadrilateral. Yep. Quadrilateral. You're going to want to memorize these. You'll know most of these already. Okay. What's a 5-sided shape? Pentagon. What's a 6-sided? Hexagon. What's a 7-sided shape?
Octagon's 8.
Octagon's 8. What'd you get for 7? Heptagon. Yep.
I know 8.
Heptagon. Kellen, go for it.
Octagon.
Octagon. Where do we see octagons at a lot?
Stop sign.
Stop signs. Yep. What about 9-sided?
Polygon?
Starts with an N.
Pentagon.
Close. Nonagon.
Octagon.
Yeah, I knew that. 'Cause, like, tomorrow.
Claire said nonagon. Brayden yelled nanagon right behind you.
Banana.
Okay. And I want to focus on one more. 10.
Pentagon.
Go for it.
Tentagon.
You're close. What?
Tentagon.
Nope. I feel like I heard someone say it.
Right.
Decagon.
I said that.
Okay. Make sure you have all 4 of these written down. We're going to be focusing on those 7 for our polygons.
What's number 3?
What?
What's a 3-sided?
Triangle.
Oh, wait.
Wait, what's 2?
Triangle. Is there such thing? So we're going to be working with those 7 for the most part with polygons. Okay. But find this. Back up a little bit to here. We're going to talk about interior angles of a polygon. Now, before I get to, let's talk about this. Interior angles of a polygon. Let's talk about, keep in mind your piece of paper. How many sides does our piece of paper have?
400.
How many sides does our piece of paper have? 4. Okay, our piece of paper has 4 sides. Now, it wants us to apply that equation right there. What do we think n stands for? The number of sides. What's the only thing you can get if I show you a shape? What's the only thing you can get from that shape? The number of sides, right? Which we have 4. So I'm going to plug in 4 for my n value. Okay? When solving this, think way back to last semester. How do I solve this? What do I have to do first? Parentheses first. 4 minus 2 is 2 times 180, which we get 360. Okay? Now ask yourself again, would it be the same answer for a heptagon? Would it be the same answer for an octagon? Would those add up to 360? Some of us are saying yes, not confidently. Some of us are shaking our head no.
I'm in the middle.
Okay. Well, let's try it. Someone say a shape. Hexagon, I heard it. How many sides does a hexagon have?
8.
Has 6 sides. So how do we find out what all of their angles add up to be. How do we figure it out? We plug it in, right? What's n? 6 minus 2 times 180. 6 minus 2 is
4.
4
4 times E.
times 180. Someone help me out. What's 4 times 180?
720. 4 times 100. Hey, turn on. Wait, I got the right.
Is it 720?
It is 720.
Okay. So, does a hexagon have the same amount of interior angles as a quadrilateral?
No.
No. So they're all going to be different. Okay? What did we just find here? What's that 720 mean?
There's 2. Wait.
That's what they all add up to. That's what all the angles add up to. In a hexagon, all the angles add up to 720 degrees. Okay, that's what we're looking for with that equation.
Can you make like a miniature one?
Let's try. What did we learn yesterday about triangles? What do they add up to? 180. If I have a box or a rectangle, think of this as your sheet of paper. How many degrees do you think all your angles add up to on your sheet of paper?
360.
It is 360, but why?
Because they're all.
It's
There's
extra side. There's 2 triangles.
Look.
What'd you say?
2 triangles and
Right, there's 2 triangles that can fit inside this square or box. You see that?
Yeah.
If I draw a line down the middle, does that create 2 triangles? Well, what do we know about those triangles?
They're 180.
They add up to 180. So what's 180 plus? Whoa. What's 180 plus 180?
900.
That's why we get that 4-sided shapes add up to 360 degrees. Okay? Can we say the same for a pentagon? Do you think they all add up to 360? Do you think all polygons add up to 360?
Yes.
Just again.
No, but
I'm not going to tell you the answer. Just think yes or no, what you believe.
yes.
Okay? Slide for me that has this shape on it. Okay, it wants us to determine whether the figure is a polygon or not. Okay, does it have 4 plus sides?
Yeah.
Yes.
Yes. Okay, are they all straight lines? Yes. What was the other thing?
Congruent side.
Are they all connected?
Yes.
Yes. What was the last part?
Congruent side.
Congruent sides and angles. That's the
Yes.
biggest part. Okay, do all of those sides look like they are the same length?
No.
Not really, no. This one
Oh, I see.
looks a little bit longer than that side. Okay, so it's no. What do you think about the angles? Do they look the same?
No.
No. So is this a polygon? No.
No.
So your answer for that is no. What if I drew this? Is this a polygon?
Yes.
Other than my terrible drawing? Yes, this is a polygon. Okay. So what you're looking for is those 4 things in order to tell if it's a polygon or not. Okay? All right. Questions about those 4 properties of polygons? Okay? Go ahead and try this one right here. Find the sum of the measures of the interior angles of a heptagon. Now, it doesn't give us a shape, but what does it give us? It gives us the name heptagon, which means 7. Okay, go ahead and use that equation and try and find the sum of the interior angles. So for finding the sum, what does sum mean? Total, right? So I'm going to use that n minus 2 times 180. So how do I solve? What do I plug in? Yep. Plug in 7 for n because n stands for what? Number of sides. Good. What's 7 minus 2? 5 times 180 equals 900. What should I label this? Degrees. Yep. Again, what does that 900 degrees stand for? The whole thing, right? All the angles added up together equal out to 900. How many angles does a heptagon have? 7. Yep, same as the number of sides. Okay. What I want you to try is go ahead and try this one. Stop sign, octagon, 8 sides. Okay. What do we do with that? Plug it in, right? Use your equation. What is our equation that we're going to use?
And then parentheses.
N minus 2 times 180. Why is the n minus 2 in parentheses? Because that has to happen first. Okay. So plugging it in, we have 8 minus 2 times 180.
6.
Yep, 8 minus 2 is 6 times 180.
1,080.
1,080. What did that just give us? Angles all added together. All of them added up give us 1,080. Is that our answer? Why are some of you saying no?
Because this says you have to find a measure of one.
Right, we have to read directions because the directions say it wants the total, or wants the measure of one interior angle.
God dang it.
So if this is all of them added together, how do we find the measure of one of those? Raise your hand if you think divide by 8. It is divided by 8 because why? Why are we dividing by 8?
Because that's how many sides there are.
Because that's how many sides there are. That's how many angles there are. Okay, so we're going to divide by 8. What do we get? 135. So that 135, again, what does that mean? What does that give us? That's the measure of one of the angles. Okay? Questions over that? I know we went over a lot.
Now that.
Okay, are we okay? All right.